Triangular irregular networks, or TIN interpolation, is another interpolation method you can find in any GIS. Here it is illustrated using ArcGIS Pro. It is not into your interpolation toolset because it works slightly different, and it's also vector output traditionally. So you would just simply have to search for TIN in your geoprocessing toolbar. Here it's under 3D Analyst Tools. You would have to give your TIN a name, a coordinate reference system, of course. And then what's nice about this is you can have multiple input features. For example, here I have two various input points. I've got points, relief points, that you can see here. These are spot heights. And then I also have contour lines. And I want to put this as an input to the TIN as well. So for both of these, my Z value, my elevation value or height value, is given in the height attributes field. For both of these, you can see the attribute table for my ISO heights or my contour lines here. So the height is giving my elevation, or for the points, it's the same. Depending on which layer you have, this might differ. The Z value will be shown in an attribute somewhere in the input layers. TINs are traditionally used for elevation modeling. These are mass points. You just have to select the most suitable one from the ones that are given to you. And then for the ISO heights or the contours in this case, it could be a soft hard or mass point. It's a hard line in this case. You can enforce constrained Delaunay triangulation. This is how TINs work. It uses Delaunay triangulation. What happens is you basically have your input points like this. You create a circumcircle that goes through at least 3 of these points, but there may not be a point inside the circle. You must have 3 on the outside, nothing inside. And you see where these circles start overlapping, and where they do, you start drawing lines to create a triangular irregular network. So once we're happy with all the input points, we run it, and you'll see that the output is actually 2 outputs. And here you can see that triangulated network. It's a bit faint, but you can see how the structure actually works. If you were to zoom to the whole layer, this is the output that you have. So the hard lines are the ones that are part of your TIN. You see them there, the hard edges. And then the actual surface is the elevation surface created in this case. It's quite a nice method of interpolation because it creates various sizing triangles in the output surface. So it's very good at representing surfaces where you have lots of input points and high variability. For example, up here on the northern edge, you can see there are high elevated values there. If you have a look at the input points, there's also quite a high density of points there. And that's the advantage of the TIN in this case, because it creates a triangle that connects these points. The more points you have, the smaller the triangle, the greater the chance of correctly capturing the variability of the terrain.